Hello students, welcome back to the maths class. In our last class, we have discussed some concepts about surface areas and volumes. We have gone through some examples and we have solved some questions those are given in your book. So today we will begin with example 12. It says a child playing with building blocks which are of the shape of cubes has built a structure as shown in figure 13.25. If the age of each cube is 3 cm, find the volume of the structure built by the child. Let us now discuss the solution. So, the age of cube is given as 3 cm. So, A is equal to 3 cm. So, let us find the volume of each cube. V is equal to A cube, that is 3 cube, 27 cm cube. Fine. So, number of cubes in the structure, you can count it, it is equal to 15. Number of cubes is equal to 15. So, what should be the volume of the structure? Volume of the structure is equal to 27 into 15. Okay, that is 405 centimeter cube. So, the structure has a volume of 405 centimeter cube. Hope you understand the example. Students, let us now discuss exercise 13.5. Question 1. It says a matchbox measures 4 centimeter into 2.5 centimeter into 1.5 centimeter. What will be the volume of a packet containing 12 such boxes? Isn't it easy? Hope you can do the solution yourself. Let us discuss. Okay. So, as per the question, length is equal to 4 centimeter. Okay. Breadth is equal to 2.5 centimeter and height is equal to 1.5 centimeter. So, volume of each matchbox is equal to length into breadth into height, that is 4 into 2.5 into 1.5, and when we do the calculation it will be 15 centimeter cube. Okay. And the question says that the packet has 12 such boxes. So, hence, volume of the packet is equal to 15 centimeter cube into 12. 180 centimeter cube. Isn't it too easy? You just need to substitute the values into the formula and you can easily find out the solution. Okay. Let us now solve question number 2. It says a cuboidal water tank is 6 meter long, 5 meter wide and 4.5 meter deep. How many liters of water can it hold? Okay. And in the question it is given that 1 meter cube is equal to 1000 liters. Okay. You need to remember this and you can find it out as well, that 1 meter cube is equal to 1000 liters. Now, let us discuss the solution. As per the question, length is equal to 6 meter, breadth is equal to 5 meter and height is equal to 4.5 meter. Okay. So, what is the volume? V is equal to length into breadth into height, that is 6 into 5 into 4.5. So, that is equal to 30 into 4.5. That is 135 meter cube, and it is given that 1 meter cube is equal to 1000 liter. So, 135 meter cube is equal to 135 into 1000, that is 135,000 liters. Okay. Hence, the tank can hold 135,000 liters of water. Hope you understand the solution for the question? Students, let us now solve question number 3. It says a cuboidal vessel is 10 meter long and 8 meter wide. How high must it be made to hold 380 cubic meters of a liquid? Okay. So, here the volume is given, that is 380 cubic meter. Length and width is given. We need to find out the height. So, let us discuss the solution. So, it is given that length is equal to 10 meter and breadth, that is equal to 8 meter, and volume is given as 380 cubic meter, or you can say meter cube. So, we know that V is equal to length into breadth into height. So, height will be volume divided by length into breadth, that is equal to 380 divided by 10 into 8, isn't it? So, it is 4.75 meter. So, the vessel must be 4.75 meter high to hold 380 cubic meters of liquid. Hope you understand. Students, let us now solve question number 4. It says, find the cost of digging a cuboidal pit 8 meter long, 6 meter broad and 3 meter deep at the rate of rupees 30 per meter cube. Let us now discuss the solution. Okay. So, as per the given data, length is equal to 8 meter, breadth is equal to 6 meter and height is equal to 3 meter. So, let us find the volume. Volume is equal to length into breadth into height, that is 8 into 6 into 3. Okay, that is equal to 144 meter cube. The question says, find out the rate of digging at 30 per meter cube. Okay, so cost of digging is rupees 30 per meter cube. Okay, now what is the total cost? Cost will be rupees 30 into 144. Rupees 4,320. So, the total cost of digging a cuboidal pit of length 8 meter, breadth 6 meter and height 3 meter is rupees 4,320. Okay, hope you understand. Students, let us now solve question number 5. It says the capacity of a cuboidal tank is 50,000 liters of water. Find the breadth of the tank if its length and depth are respectively 2.5 meter and 10 meter. Let us now solve it. Okay. So, what is the given data? Capacity is 50,000 liter. Okay. 50,000 liter is the capacity. It is not the volume. Okay. So, we know that 1 meter cube is equal to 1000 liter. That means 50,000 liter is equal to 50,000 divided by 1000, that is 50 meter cube. So, the volume of the tank is 50 meter cube. Now, what are the given data for the dimension of the tank? It is length is equal to 2.5 meter and height is 10 meter. That means volume is equal to length into breadth into height. That implies 50 meter cube is equal to 2.5 into B into 10. That implies B is equal to 50 divided by 2.5 into 10 or 5 into 10 by 25 or it is 2 meter. So, the breadth of the tank is found to be 2 meter. Hope you clearly understand the solution of this question. Students, let us now solve question number 6. It says a village having a population of 4,000 requires 150 liters of water per head per day. It has a tank measuring 20 meter into 15 meter into 6 meter. For how many days will the water of this tank last? Okay, so let us discuss the solution. What is the dimension of the tank? Length is equal to 20 meter, breadth it is equal to 15 meter and height is equal to 6 meter. Fine. So let us now find the volume. Volume is equal to length into breadth into height, that is 20 into 15 into 6. 300 into 6, that is 1800 meter cube. Fine. So water required per head per day is 150 liter, isn't it? So water required for 4,000 people to be found. So water required per day per head, it is given as 150 liter. 150 liter. So for 4,000 persons, it is equal to 4,000 into 150. Okay, it is 6 lakh liter. Okay, now we need to convert. Okay, we need to convert into the volume. Okay, so we know that 1 meter cube is equal to 1000 liter. That means 6 lakh liter is equal to divided by 1000, that is 600 meter cube. So this is the volume of water required for 4,000 people. Okay. So students, we have found that volume of tank is equal to 1800 meter cube and volume of water for 4,000 people is equal to 600 meter cube. So let us find how many days the water will last. Okay. So water will last for volume of tank divided by volume of water required for 4,000 people. Okay, that is equal to 1800 meter cube divided by 600 meter cube. 3 days. Okay, so the water of tank will last for how many days? 3 days. Hope you understand the solution for the question. Students, let us now solve question number 7. It says a godown measures 40 meter into 25 meter into 15 meter. Find the maximum number of wooden crates, each measuring 1.5 meter into 1.25 meter into 0.5 meter that can be stored in the godown. Let us now discuss the solution. So the dimension of the godown is length is equal to 40 meter, breadth is equal to 25 meter and height is equal to 15 meter. So volume is equal to length into breadth into height, that is 40 into 25 into 15, that is equal to 1000 into 15 or 15,000 meter cube. Okay, we have found the volume of the godown. Now let us find the volume of each crate. Okay, so dimension of the crate is length is equal to 1.5 meter, breadth is equal to 1.25 meter and height is equal to 0.5 meter. So, volume is equal to 1.5 into 1.25 into 0.5, that is equal to 0.9375 meter cube. Fine. Now, maximum number of wooden crates that can be stored in the go down. Let us find it out. Maximum number of crate is equal to volume of the go down divided by volume of each crate. Okay. So, what is the volume of the go down? 15,000 meter cube divided by 0.9375 meter cube, and when you calculate, it comes up to 16,000 crates. So, maximum number of 16,000 crates can be kept inside the go down. Okay. Students, let us now solve question number 8. It says a solid cube of side 12 centimeter is cut into 8 cubes of equal volume. What will be the side of the new cube? Also find the ratio between their surface areas. Let us discuss the solution. What is given? Side of the larger cube. Side of the larger cube. Let's take it as A1. So, volume is equal to A1 cube. So, the volume is equal to 12 centimeter cube. Okay, that is 1728 centimeter cube. Fine. So, the cube is cut into 8 equal cubes of equal volume. So, volume of smaller cube is equal to 1728 divided by 8. So, it is 216 centimeter cube. Fine. So, if the edge of the cube is to be taken as A2, now we have found that A2 cube is equal to 216 centimeter cube. That means A2 is equal to cube root of 216, that is equal to 6 centimeter. Now, we need to find the ratio of their surface areas. Okay, let us find it out. So, students, we have A1 is equal to 12 centimeter and A2 is equal to 6 centimeter. What is the formula for surface area? 6A square. That means ratio is equal to 6A1 square divided by 6A2 square. That is equal to 6 into 12 square divided by 6 into 6 square. That is 144 divided by 36. Okay, that is 4:1. So, ratio of the surface areas of the larger cube and the smaller cube is 4:1. Hope you understand this. Students, let us now solve question number 9. It says a river 3 meter deep and 40 meter wide is flowing at the rate of 2 km per hour. How much water will fall into the sea in a minute? This is a tricky one. You just need to understand that the river is 3 meter deep and 40 meter wide, and it is flowing at the rate of 2 km per hour. It is flowing with a rate. Okay. Students, let us now discuss the solution for this question. Okay. What is given? Depth of the river. Depth means height. So, height is given as 3 meter and the river is 40 meter broad. That means B is equal to 40 meter. Okay. we need to find out how much water will fall into the sea in a minute. And the rate of flow is 2 km per hour. That means it is flowing like this. So, it is covering a length, isn't it? If the river is flowing like this, suppose this is the river and it is flowing like this. That means it is covering certain length. Okay, the length covered is 2 km per hour. Fine. So, per minute, it is asked that how much water will fall into the sea in a minute. So, we need to find out the distance covered in a minute. Okay. So, the length or the distance covered by the flow of water in 1 minute will be 2000 divided by 60, or it is 100 by 3 meter. Now, we have found out the length. Okay, let us now find the volume of water. So, students, what should be the volume then? Volume is equal to length into breadth into height. So, length is found to be 100 by 3, breadth is 40 and height is 3 meter. So, 4000 meter cube. So, the volume of water that will flow in 1 minute is equal to 4000 meter cube, which will flow in 1 minute in that river. Hope you understand the solution for this question. Let us now discuss the volume of a cylinder. Okay? Just as a cuboid is built up with rectangles of the same size, we have seen that a right circular cylinder can be built up using circles of the same size. So, using the same argument as for a cuboid, we can see that the volume of a cylinder can be obtained as base area into height. Okay, because they are of same size. So, all the circles have same area and they are covering a distance or a height. So, area of a circular base into height. Okay. So, what should be the volume of the cylinder then? Volume of the cylinder is equal to area of circular base pi r square into height. So, pi r square h. So, this is the formula for finding out the volume of a cylinder, which is having r as its base radius and h is the height of the cylinder. Hope you understand. Students, let us now discuss example 13. The pillars of a temple are cylindrically shaped. Just see the figure 13.26 that is given in your book. If each pillar has a circular base of radius 20 centimeter and height 10 meter, how much concrete mixture would be required to build 14 such pillars? Okay. So, let us discuss the solution. Students, since the concrete mixture that is to be used to build up the pillars is going to occupy the entire space of the pillar, what we need to find here is the volume of the cylinders. Okay. So, the given data is radius is equal to 20 centimeter, fine, and height is 10 meter, that is 1000 centimeter. Okay. So, what is the volume? Volume is equal to pi r square h, that is 22 by 7 into 20 square into 1000. Okay. That gives us 22 by 7 into 20 into 20 into 1000. That is by 7. So, students, this is in centimeter cube because we have taken the unit as centimeter. So the volume is 88 lakhs centimeter cube. Okay. So we know that 10 lakh centimeter cube is equal to 1 meter cube. Okay. So this is to be converted to meter cube, and when we convert it to meter cube, it becomes 8.8 by 7 meter cube. When we divide 88 lakh by 10 lakh, it gives us 8.8. So 8.8 meter cube, and the volume will be 8.8 divided by 7 meter cube. Okay. Now volume of 14 pillars we need to find out. So what we need to do? We just need to multiply this value into 14. So let us do it. So volume of how many pillars? It is 14 pillars. 14 pillars is equal to 8.8 divided by 7 into 14. 7 2s are 14. 17.6 meter cube. Okay. So the volume of 14 pillars is found to be 17.6 meter cube. So what was the question and what we were needed to find? The question says how much concrete mixture would be required to build 14 such pillars. Because the volume of 14 pillars is 17.6 meter cube, that means this much concrete mixture would be required to build 14 such pillars. Okay. Hope you understood the example, students. So with this we end today's session. In this class we have studied many concepts about surface area and volume. We have gone through the examples and we have discussed some of the solutions for the questions given in your book. In our next class we will learn some more concepts about surface area and volume. Till then, keep practicing and have a good grasp on mathematics. Okay? Thank you.